I want to look at a little bit of these solving problems from this week on volume. I want you to look at this problem and know that it says here we're making a candle mold. It's going to be a rectangular prism, which is like a shoebox. And we know that the volume, when you do the length times the width times the height of that shoebox, is going to be 28 cubic centimeters. And I also know that the sides have to be whole numbers. So the question is, how many different molds can she make? How many different ways can that shoebox look differently? And so I'm just going to, I use shoebox so you get the idea of that three-dimensional shape. But it could be long and skinny, it could be tall and skinny, short and fat, as long as the volume equals 28 cubic centimeters. So to get an idea of that, I just start up here, and to see what length times width times height can equal 28. So I can start with 1 times 1 times 28. And that equals a volume of 28 cubic centimeters. That would be a very tall, skinny box to make a really tall, skinny candle. So that's one way it could be. So I just look at the different kind of fact families that will give me the 28 cubic centimeters. So another fact family is 1 times, and I'm going to look, what multiplies out to give me 28? So I know that 1 times 2 times 14, that would equal 28 cubic centimeters. So this could be another shape to make a candle. This one is super tall and skinny because it goes up 28 centimeters. This one's not quite as tall and skinny. It only goes up 14 centimeters, but it's a new shape of a box. Then I look out here and I say, what else could I do? I could have 1 times 4 times 7 would equal 28 cubic centimeters. So when I look at that, my box, my candle mold is a lot shorter. So, and it's a little wider, but it's 1 by 4 by 9 when I look at that three-dimensional candle mold of trying to make a shape from candle mold. So this is the process to begin for figuring out how many. And if you continue through this process, you would see that there were 10 different molds that could be shaped there. So let me move over here and move down. So now that we have all the molds, we want to know which of those molds would have a square base as opposed to a rectangular base. So when you look up here at your choices, you're going to look for a base that would have equal or congruent sides. This one right here would have a congruent side. 1 times 1, if the base was 1 centimeter by 1 centimeter and then 28 centimeters tall, then the base would be a square. So as you work through these 10 different molds, then you can figure out how many of them have the square possibilities of that. So that would help you on that. Let me clear this out real quick. On number 4 of that same page, Jeff has a small box. He has a small box that's 12 by 8 by 4. He has a taller box that's 20 by 15 by 9. If he puts the small box down inside the large box, how much room is he going to have left to add stuff? So if this was a small cereal box and a large cereal box, and he put the one down inside the others, how much room would he have? So all you have to do on that is figure the two volumes. So the larger box is 20 times 15 times 9. Figure out the volume. And then you're going to come over here and find the volume of the smaller box, which was 12 times 8 times 4. And you find that volume. When you know these two volumes, to find out how much space is left is like finding the difference. So you subtract those two numbers, and that becomes your answer. So I just kind of wanted to give you a few little hints and tips on that. And then the last thing I want to go over is down a little bit on finding the volume of composed figures. Of these three-dimensional figures, again, finding the volume is the same, is length times width times height. But on this particular figure of number 1, it's really hard for me to figure out the length times the width times the height. This really looks like two figures to me. So what I do is I find the volume of one figure and I add it to the volume of the other figure. So you can easily do this by breaking it into two shapes. And I see this like an upside down T. So I'm going to find the bottom dimensions and I'm going to find the top dimensions. Now if I look at this bottom, it looks kind of like a flat cereal box. And I can see right here going across is 4 inches across. It is 2 inches depth and a 1 inch height. So that one is really easy for me to figure out. So the bottom one, I'm going to say 4 times 2 inches times 1 inch, and I'm going to come up with the volume of that flat cereal box. Now the issue becomes finding the dimensions of this standing cereal box right here. And all I know is from here to here is 1 inch. I don't know this number. And let's see, do I know the width going from here to here? I do. That's 2, isn't it? So I know that this is 1 inch and going across here is 2 inch. But what I don't know is the height. But what I can see over here is the height of the whole figure from top to bottom is 3 inches. And I know that this bottom piece right here is 1 inch because it said so right over here. So if from here to here is 1 and I need to go all the way up to the top, 1 plus what will give me 3? 1 plus 2. So I know that the height of that box is 2 inches. So the second box is going to be 2 times 2 times 1. And I will find some sort of volume there. When I do, I add those two volumes together to get the total capacity that we have. Hope this is helpful.